Thank you so much for presenting to our students today, Bojana, and welcome.
Thank you very much. Thank you for the introduction. That was a good introduction, and I'm glad that all the different areas that I will be covering today are being mentioned. Just a little bit of the background intro. I am a linguist, but at some point during my master's and my PhD, I switched to neuroscience and neuro-linguistics of language and psycholinguistics of language, which is a different approach to linguistics, which I will be talking about. And I think it's appropriate because it really underlines the interdisciplinary approach that we all want to do nowadays in science. And that is very important also in the relation of research and industry, actually. So I will first start with a little bit of lecture overview. So I will first talk about the linguistics in general, the fields of psycholinguistics and neuro-linguistics, which are very new, also clinical linguistics and other applications of linguistics, such as forensic linguistics, and most importantly, something that is very important today, which is computational linguistics and natural language processing. So first of all, what is linguistics? There is a little bit of misconception when people say linguistics. A lot of people think that it has to do with learning one particular language. While we can focus on linguistics of only one language, general linguistics as a science actually wants to study language as a system, the faculty of humans to be able to understand language and produce language. And we are trying to describe this general property of this general cognitive property, which is part of our cognitive system, to speak and use language. This is very important because I will go back to that of how difficult actually it is to describe such a complex system that is language. But linguistics actually has many, many different subfields. And these subfields have to do with what about language you want to focus on. We now know that language is a system where we have smaller units that are, let's say, a superficial knowing of the language, such as phonemes, those are the sounds, or graphemes, those are the symbols when we write. But we know that from these smaller units that we combine them into bigger units that are called morphemes, which are basically chunks of words that constitute words. And then these morphemes are bound together to form words. And then words together are combined according to syntactic rules to form sentences. And these sentences have not just the structure, but also the meaning, both separate words, but the combination of words have separate meanings. And then these sentences can combine into text or bigger chunks of speech that again can have a different meaning and connotation when in certain contexts. So there are many layers of studying a language, and you can focus on different units of language. This is how we call them, the units. Now, there are also different linguistic branches or approaches to study this, right? What I mentioned first, which is just describing the language, this is something that theoretical linguistics gives us. But if we want to say study this from a perspective of linguistics of one language or another, we are talking about comparative linguistics. If we want to study, for example, how the society in which you live affects how you use or understand language, we're talking about sociolinguistics, etc. One of them that I will be first focusing on, these are only some approaches to linguistics, is psycholinguistics and neuro-linguistics. Now, I am putting these two together because actually they both focus on they're overlapping. Actually, to say it in a most simplistic way, we can say that psycholinguistics studies language in the mind, whereas neuro-linguistics studies language in the brain. So neuro-linguistics would focus on the neural basis of the language, which is the brain. So the actual biological organ, the actual anatomical parts of this brain organ that allow us to process language. And so that allows us to process language. And that language processing, basically the relation between language and thinking, and how, for example, how much time we need to plan what we want to say or to understand the words. That's only one example, but it's an example for what psycholinguistics deals with. So how we process language. And then neuro-linguistics is how these processes are actually, what are the physical underpinnings of these psychological cognitive processes. Because as I said, language is one of the cognitive functions that we have. It collaborates really, really tightly with memory. So these are some of the processes that are the cognitive processes that are happening in our mind. But both psycholinguistics and neurolinguistics can focus on different subfields if we are talking about these different language levels or language units, and we can tackle them from a different approach. Often we choose a phenomenon that we want to study and study it from both psycholinguistic and neurolinguistic point of view. Now, when it comes to the neurolinguistic point of view, how do we get to know that this is something that we can study? Well, we now know that there are areas in our brain that form the so-called language network in the brain that are responsible for language processing. This is a rather simplistic language processing model called Wernicke-Gershwin model, where you can see some of the main areas in our brain, which are mostly on the left brain hemisphere, that are responsible for us understanding and producing language. The primary cortex is usually the motor cortex for most of our functions, and also for the language. So this is where we will plan production of the language, and this is the production part. Whereas the temporal lobe is more focused on understanding the language. And it is very important that these areas communicate through the white matter pathways. So we are not just using the gray matter and the surface of the brain, but also different areas of the brain communicate throughout these pathways that are all over our brains. And they communicate with some other areas that are not specifically linguistic. So, for example, the blue area here is primary auditory cortex, which is basically where the information goes when we hear something. So it will first be processed in the auditory motor cortex, and then it will be sent to more language-related areas throughout these pathways. However, if we read language, the information will first go to the back of the brain, the so-called occipital region, which is the primary visual cortex, which is active when we see both language and any kind of visual information. And then from there, it will be sent to language centers to be processed further. So this is based on decades of research. We now know that there are areas in the brain that language is indeed as something that we can find in our brain, so to speak. Although in the beginning of language science, we thought that there is only one particular brain region that is responsible for us being able to speak, the so-called language acquisition device that was suggested by Chomsky. But we now know that it's not just one area. We know that some areas of the brain are more specific to language, some are less, but a lot of them communicate for us to be able to speak, because language is such a complex system. And also, as I said, this is quite a simplistic view. After some decades of research, we now know that there are so many areas in the brain. This is a very huge part of the frontal cortex and of the temporal cortex that we now know that is active when we do different kinds of language-related tasks. And we now know, using a very contemporary MRI technique called DTI, that these white matter pathways are also being activated and serve to send information throughout the brain when we are speaking or listening or reading. So how do we know this? How do we investigate language? We usually investigate where and when certain rules are applied. Given that language is a system, and this system has its certain rules that need to be followed in order for us to understand and use language accurately. So the way in which we measure where language is processed and when, which is very important because language develops in time. We use machines that measure the location and the timing of the processing of the language. For example, here we have the magnetoencephalography, and this is the EEG, electroencephalography, which are very widely used in language research. And for example, we know that our brain follows certain rules because what the brain does is responds when the rules are violated. So using EEG, this is a very well documented an effect. When we compare the brain activity during reading the sentence, listening the sentences such as "I drink my coffee with cream and sugar" versus "I drink my coffee with cream and dog." Upon hearing the word dog, if you can see here, these lines, the blue and red line is brain activity. And time zero is when you hear the word dog or sugar. And you can see that upon hearing the word dog, there is a significant change in one of the areas of the brain that is language related. And this happens consistently. And it happens around 400 milliseconds after hearing the word. So we know that our brain follows these rules and that it responds to certain rules by creating experiments where those rules are violated. Excuse me. So this is the way in which we investigate. For example, in this case, we have investigated the lexical semantic properties of which means the word meaning, right? Given that we have encountered the word with an unexpected meaning, our brain is responding to that. If we look at the area in the brain which responded to that violation, we can tell that that area in the brain indeed is responsible for processing the meaning of the words. So this is how we do these experiments. Now, what would be the application of this? So far I've been talking about a typical language processing of a neurotypical individual. But the application of this is in the clinical linguistics. And clinical linguistics has also informed us a lot about neurotypical population too. That means that we can find out how the population that has no neurological disorders, how they process language, so that we know how to treat and how to tackle the population that indeed has some language problems that are due to some brain damage. And this is the field of clinical linguistics. So for example, going back to that Wernicke-Geschwind model, and the areas that are important for language processing, we now know that Broca's area, which is in the premotor cortex, is the area where we that is mostly responsible for production of language and language speech, right? So the actual motor movements. Whereas this one here, the green one, Wernicke's area, is mostly for language comprehension. And indeed, people who have brain injury in Broca's area have problems with producing speech, although they understand what you're telling them or what they read. Whereas people who have a damage in Wernicke's area are very fluent and produce a lot of speech. However, it doesn't make a lot of sense because their language comprehension is very impaired. So these types of injuries of brains are called aphasias, and this is a very widely investigated topic in clinical linguistics. So that is the inability to comprehend and or use language because of the damage to the specific brain regions. And these are the two most common ones that I just mentioned: Broca's aphasia, which causes impaired production and disfluency. And these people are usually very aware that they have a problem, and it causes a lot of frustration because they understand everything, they know what they want to say, but they cannot. Whereas Wernicke's aphasia is it's a very fluent one. People can speak a lot, but the sentences can be very can make no sense, or the words that are chosen, although the syntax might be fine, and the grammar, but the words that are chosen can be very very random. Clinical linguistics then is a discipline that involves description, analysis, and treatment of language disabilities. Aphasia is just one of the language disabilities. We can have different language disabilities, for example, stuttering, or something. Oh, aphasia is the most common one. Also, for example, some reading difficulties, such as dyslexia. For all this, we use actually the knowledge from linguistics to try to explain what we have with the normal population and what might be impaired in people who have any kinds of problems. So the linguistic concepts and theories are applied to assess, diagnose, and administer language disorders. For example, here in the linguistic field of phonetics, which is studying the sounds of the language, we have now defined different speech phonemes. These are different sounds and how they are produced. For example, the word cut consists of 3 phonemes, k, t, right? And for example, we know the normal population is aware and can segment words in these phonemes. One of the features of us, of our understanding of the language, is being able to segment speech into smaller units. But we know that people who have some language problems or speech disorders, the problem actually lies in inability to segment speech, either sentences into words or words into phonemes, right? And different, which affects fluency. And then we can use that knowledge to try to come up with a therapy for these people. So this is the application part. What we do in clinical linguistics is, first of all, we create standardized and normed tests to be able to diagnose these. There are a lot of tools that are they consist of the different language tasks, linguistic tasks, that we use to diagnose people with certain problems, speech or language problems. And then we can create therapy for them based on what we know. Most common one is speech language therapy, which is there are different kinds of tasks here, repetition of certain words, depending on what the problem with a particular person is, helping the person segment sentences, helping the person name objects, helping the person create longer and longer sentences. Sometimes that is a problem. Sometimes therapy is nonverbal, including just drawings and pictures. And one relatively new a method of helping people which have speech and language disorder, especially with aphasia. And that has to do with what we know from neuro-linguistics and about different brain regions that are responsible for language processing. One new method is the so-called transcranial magnetic stimulation, or TMS, which is the stimulation of certain brain areas that are responsible for language, certain language functions. By using it, we modulate the brain activity of the cortex only. No, it doesn't go to the white matter. This is painless, it's safe, it's simply a modulation, stimulation of brain activity. But together with the intensive speech therapy, so doing these kinds of different language tasks that I mentioned, it can actually, and there are studies, more and more studies nowadays that show that this can contribute to the improvement of aphasia and improvement of language abilities. And for this, of course, we have to have knowledge from the neuro-linguistics about how the brain functions and where certain areas are, but also to adapt this therapy to the particular case of a person, because it's really rarely that a person only has Broca's aphasia clearly and Wernicke's aphasia clearly, because aphasias are caused by a stroke or brain injury. They can be also neurodegenerative, such as with dementia. And it's really rarely one very well-defined region of the brain. So it is usually a mixture of different aphasia types. So we have to adapt these therapies to the particular individual. So this was a little bit about how we can use both theoretical linguistics and neuro-linguistics knowledge to help patients that have some problems with language or with speech. Now, going back to the linguistic branches and approaches, I would like to move to a completely different area of applied linguistics, where we can also use our theoretical knowledge, and that is forensic linguistics. And forensic linguistics is basically the application of linguistic knowledge and methods to the forensic context. That means in law, in crime investigation, and in certain judicial procedures. So what a forensic linguist does is they perform language analysis, either text or speech, to help solve crimes. And this is sometimes very important in certain cases, and can be a decisive factor in solving crime. This analysis is performed based on the knowledge of the linguistic theory, of course. So what a forensic linguist can deal with is, for example, the identification of the authorship of certain texts, which has to do with plagiarism. A forensic linguist can help with determining word meaning, clarifying legal language, which can help solve whether something is related to criminal activity, such as bribery, extortion, etc. The forensic linguist can solve some contract disputes, fraud, etc. Help understand jury instructions, copyright issues, etc. So these are some examples also. For example, a forensic linguist can establish possible authors of documents through grammatical and stylistic analysis. For this, we use our knowledge from from orthography, which is basically how to write, or text analysis. Text analysis relates to analyzing, detecting features and characteristics of text that relate to a certain person. It can help. Analyze meaning of words in contracts, statutes, and law. For this, we need the knowledge from semantics and lexicology. Semantics is the study of meaning of words. A forensic linguist could also help interpret lip reading from videotapes when there is no sound. Why? Because a phonetician would know how certain sounds are being produced and would be skillful enough to help lip reading some videotapes. Then also, the speech act analysis of language was speech that would be pragmatics. The pragmatics is meaning of sentences in context, right? So in this case, a forensic linguist would help to, excuse me, if you could turn off your mics, that would be helpful. A forensic linguist could help clarify whether something constitutes a confession, a threat, or a conspiracy, and these are the so-called speech acts. The speech act is like not a literal meaning of the sentence, but what is the act of this sentence, what I am doing with this sentence. Am I confessing? Am I apologizing? Am I threatening? Am I asking for something, promising something, etc.? These are called the speech acts. And indeed, a forensic linguist could help solve whether this is the case or not. Okay, so this was a little bit about another branch of applied linguistics called forensic linguistics. Now, in this part, I would like to focus on the computational linguistics. Computational linguistics is a relatively, it's not such an early, it's not such a new branch in linguistics, in applied linguistics, but it has flourished in the last decade or two. This is the branch of linguistics which actually uses the techniques of computer science. The techniques of computer science are applied to the analysis and synthesis of language and speech. This is especially been possible in the last decades with the large corpora, with large sources of texts, especially from Google, right? Where we have access to big bodies of text that we can then analyze in different ways and extract a lot of information that we can use to create different kinds of applications. I will talk about that a little bit more. So with computational linguistics is based on modeling the language. So trying to make a model of the language that will help technology, computers, to better process the human language. So that means creating certain programs or applications that will communicate with technology. This is what a computational linguist does, to help communicate with the technology, with the program, to help computers follow human commands or do certain tasks. And I will walk through different kinds of tasks. It has emerged as an area of artificial intelligence. It dates back from Turing, and it is dominated by using statistical methods in modeling the language. And the methods that are mostly used are neural networks and machine learning. Machine learning, you might be familiar with that, but machine learning is relies on using algorithms and statistical models to analyze big data sets. And importantly, to be then able, when you train, usually a certain smaller data sets are trained to be able to draw inferences. This is a very important part of machine learning. That is the learning part, to draw inferences and make predictions from certain patterns of data that are provided in the training data set, but then to draw inferences and analyze data, the bigger data sets based on what's been learned and inferred from the training set. This creates computer systems or programs that are able to learn the rules. Again, remember that language is a system with rules. To learn the rules and adapt when you get a new input that you haven't been trained on, without following explicit instructions, but to learn and extract the rules from new sets of data on their own. This is called machine learning. So The statistical methods are based mostly on machine learning. That has been the dominating method in the 90s and 2000s, but lately, in the last decade or so, another, let's say, sub-branch of machine learning has emerged called neural networks. And neural networks are types of machine learning process called deep learning. It's called neural network because it has been based on, inspired by the actual brain, so by the biological neural networks, where we have neurons that are connected, and the information is sent between them, between the also different areas of the brain. And in order for the neuron to activate, we need to reach a certain threshold. So these are the two. Sorry?
Bojana, how are you? Thank you very much so far for an excellent presentation.
Yes.
We had a student actually say, wow, this is the best presentation we've had so far, and we've had quite a few. So congratulations so far.
Thank you.
The other thing I wanted to mention is Dr. Valsine is on. As I shared with you, there was an issue with the meeting ID we shared with him, but we were able to get the correct meeting ID over to him. So he is connected now. But since we're a little bit past the halfway point, I just wanted to ask, number one, give our students the opportunity to ask any questions. If you want, you can raise your hand. Right now, I have my hand raised, so our students can go to reactions and raise their hands. And also, as far as how you're doing so far, would you say you're about maybe 60% done with the presentation?
More than 60. More than 60.
Okay. So maybe it is a good time to welcome some questions. Let me see.
We do.
Okay, let's see. Does anybody have any questions so far for our presenter, Bojana?
Yes, I can see one hand.
Once again, thank you very much, Dr. Gonzalez. Thank you very much, Bojana, for your presentation that has proven to be really outstanding up to this point. But I'm personally delighted. I've been a language acquisition professional for the last 40 years, and I'm learning significantly from your presentation. But I'm not gonna continue and make personal comments about this. Your session is essentially intended for our students, our attendees, and we have two hands up at this point, and we're going first to Tangavel Copen. Go ahead, Tangavel, ask your question, please.
Thank you, sir. Good evening.
Good evening.
Ms. Bojana, I really appreciate your presentation very much.
Thank you.
I am from Mauritius, a small island in the Indian Ocean. So we are a multiracial country. Our mother tongue is a Creole. So we learn so many languages here. We learn English, French, Tamil, Telugu, Marathi, Arabic, Urdu, so many languages. So I am a Mauritian. I speak Creole, but when I'm going to speak in English, I tend to translate from Creole to English, from Creole to French, from Creole to Tamil, etc. So sometimes we miss some words. Say, what can we do? What make us forget some words? Is it a translation, or how can we be fluent in in English, French, etc.?
Yeah, that is a great question. The great point that you mentioned, that when you speak a foreign language, you're translating from your own language. There is actually several theories about foreign language learning, and some of them say that depending on how proficient you are in your second language, you will either build up on your mother tongue which is probably what we are doing. But at some point, when becoming proficient enough, we don't go through our mother tongue. Although some theories say that we always do, I have to say. But the only way to become more proficient is by using it more and by exposure. The way and the speed with which we access words, either in our first language or our foreign language, largely depends on the frequency of usage. So how frequently we use it and how frequently it is used in our environment. So so that is the only way to use it more frequently, to be more exposed to it, and so to increase the frequency of usage and exposure.
Let me jump in real quick to make a further comment about that. Tangovel.
One more.
I've been a professional interpreter myself as well for the last 35, 40 years. I do speak several languages, pretty much like you, and I do serve as an interpreter. One thing that I teach my students is to be careful to avoid translating literally, which means word to word. If you get into this trap, you're in trouble. So I teach my students to learn about the notion of context. You've got to get the context. What you are translating is not actually the words, but the context. It's like, for example, if you're saying, my stomach is empty, well, that's paraphrasing, I'm hungry. And you don't need to know the word empty. You don't need to know the word stomach very specifically. As long as you grab the context, you're in good shape to translate whatever you hear accurately in a way that both the speaker and the listener can fully understand each other. So again, bottom line is to try to practice to use context, context translation instead of word-to-word or just verbatim translation. Let's now go quickly, if you don't mind, Ristic, to Andrew Walkowo. You have the floor, Andrew. Your microphone is off, Andrew. At the bottom of your screen on the left, you will see the icon for the microphone, please.
Yeah.
Here we go.
Yeah. Good morning, Dr. I think Fasing. I don't know if I pronounced that very well.
Good morning.
Yeah. Good morning. I'm the Dr. Ms. Bojana. Good morning. Yesterday is my second time of tuning into the online lecture, and yesterday halfway I had technical problem because though I'm an Irish Nigerian, I'm presently in Lagos, so I had technical problem and I was cut off. So, but the situation is that I don't know, is the lecture recorded or are there notes that I can fall back to?
It is.
Yeah, let me add something for you, Andrew, and for every other attendee. Whether you are joining us for the first time or you are an habitual attendee or participant, all the sessions, all the live class sessions are recorded, and very soon, after, let's say, a few hours or maybe 2 days, the recording will be put in your student portal. And so within 2 days, everything you hear right now, you're going to get them back for you to go from beginning to end, in the middle, pause, reverse, and so forth and so on. The entire session will be within your student portal to do whatever you please with the session. Thank you.
That is great. Thank you very much.
Gozi Ogro, your question, your comment, please.
Thank you very much. And thank you, presenter, for this very insightful session. I'm sorry I'm not able to come on camera. I wanted to know from the viewpoint of a medical, a neuro-linguist, if someone had something like an infarction and then you completely lose your speech. You're not able to speak. From the analysis of the brain, is the linguist able to know what happened? And are you able to regain speech by therapy to be organized by the linguist without medications? Because my idea of linguistics has completely changed from this presentation, and I think I'm pleasantly, disposed to this presentation. Thank you very much.
Thank you for that question. The first part of the question, if I understood well, it depends on what type of aphasia you have. People are very often unable to speak, although they understand what is happening around them. But sometimes it's the other way around, or they are not able to speak at all. So it depends which part of the brain is damaged and how big the damage is. Now, when it comes to recovery, there are many factors. One of the factors is actually one of the many important factors after a stroke and the recovery is how old people are. The younger the brain, the more able the brain is to recover. The brain has this great feature that is called brain plasticity, meaning that the brain is able to reorganize itself and maybe find new ways and new pathways, build new pathways so that new functions are acquired. This definitely depends on the type of injury, the age, and the plasticity of the brain itself. Individuals differ with respect to this, but language therapy can help on its own, again, depending on the individual. So there are cases where a person is completely unable to speak and recover speech. Usually we know within 6 months how things will develop. Then you kind of reach a plateau. But it really depends on the patient themselves. Yes, language therapy is a very important aspect of it. Whether it is possible without medications, I don't know, because what people do is usually combine different treatments. Because you don't want to risk not having the best possible treatment. But it is very true that the language and speech therapy is a huge factor, because it simply stimulates the brain, and this is how we improve brain function, by stimulation. So this is the.
Thank you very much.
Thank you for your question.
Thank you again very much, Ms. Bojana. So at this stage, I would recommend you continue with your presentation so that we have at the end a few minutes for additional questions.
Perfect, thank you. Okay, so I stopped at neural networks. So going then further, let me check. To the natural language processing. Natural language processing is can be considered as a synonym to computational linguistics. This is a mixture of linguistics, computer science, and artificial intelligence. And it's based a little bit more than computational linguistics, that can be also theoretical. So computational linguistics is maybe more focused on modeling the language. Natural language processing is focused more on using what we know from machine learning and artificial intelligence to enable and make these applications and these programs to enable the interaction between human language and computers. So it boils down to solving the issue of how to make programs, computer programs, process and analyze large amounts of natural language. By natural language, we mean human language, as opposed to computer languages, such as Java and Python. So how to make them, how to analyze them. Now, this might sound simple, but it's actually very hard. With all the linguistic knowledge and theory that we have for decades, it's very hard to fully describe human language in terms of generalizable rules and commands, right? Given that language that language is, well, the first language is acquired, not learned. And that even if we are learning language as later in our lives, we are learning a lot of things subconsciously, right? We are not always instructed into rules, and we as language users don't always think about it. But even people who think about language, such as linguists, find it really hard to describe language in terms of a list of rules and commands that will cover all aspects of language, and importantly, in all the contexts, right? This might work to some degree for rules such as grammar rules and linguistics, and indeed syntax, the field of syntax in linguistics, has been developed in terms of trying to define the rules that we use to combine words to create sentences. But describing the rules explicitly to tell to the computer to explain meanings of the words, especially meanings of the words in the context, that has been a very difficult task. So the final goal in natural language processing, NLP, is for a computer to find a computer or create a program that is capable of understanding, let's say, the contents of different text documents, or actually even speech documents, right? And this is what I mentioned before. For this to be successful, this means that a computer has to understand everything, and even these contextual nuances of the language within them. Once enough input and enough explicit instruction and explanation has been given to the computer, then the computer can actually extract information from a new text it gets and perform different types of analysis, and then based on that, different types of tasks that you as a computer user might have related to anything that involves text or speech. So what are the examples of these tasks or commands that we as computer users might have? So text and speech processing, such as, these are the tasks. So a natural language processing linguist might deal with optical character recognition. What that means is when you have a scanned document, the program should detect the letters within that scanned document, which sounds simple, but it's not, because there's a lot of variety in the shape, etc. Speech recognition has been one of the biggest tasks in NLP. Why? Because when we speak, although we perceive words as different units, but actually when we speak, it's all one chunk of speech that we are able to parse and chunk based on our knowledge. But a computer, without having the language knowledge, has to be told where the limits between the words are, and making a rule that is general and that applies to different kinds of speech and, let's say, different kinds of audios is really difficult. That's related to speech segmentation. Text to speech or speech to text is one of the tasks, meaning the programs that might transfer or transcribe the text into spoken language and vice versa. So other tasks are, for example, being able for a program to detect morphological, so having to do with word structure, and syntactic segmentation of a sentence, so detecting grammar rules, detecting lexical semantics, so the semantics of a separate word, and the meaning of that word in the context. So this is, for example, now to tell you what are different applications, and I have taken this nice graph from the website Data Science Dojo. These are different applications of natural language processing. For example, language translation, such as Google Translator, is based on NLP, natural language processing, meaning that you had in Google, there are a lot of linguists that are computational linguists, and inserting a lot of rules about the language. This is why sometimes the translations are bad, sometimes the translations are good, because some things are harder to, for example, if you want to translate a single word or maybe one phrase, it's usually very accurate. But if you try to translate a joke, or let's say some kind of idiom, something that is very language specific and depends on the context, Google is not really good with that. Also, Google is better for the languages for which it has a lot of data, such as English, but not really good for languages for which there isn't a lot of data, because of those machine learning mechanisms that need big data sets to learn and extract these rules. Smart assistant on your phone, document analysis, online searches work based on NLP knowledge. When we are typing in messages on our phones and we have these predictions and suggestions, that is based on natural language processing, because based on these data sets, the programs are predicting what the next word might be, following the rules of the language. Also, the chatbots that we have in certain websites that we can talk to are actually artificial intelligence based on natural language processing. And then we can use use these natural language processing programs to do some kind of research. For example, in marketing, we want to do social media analysis of posts on Twitter or Facebook. Well, based on what we know from NLP, we are able to extract the texts and analyze them, and then do the analysis that we want. Also, the smart assistant, such as the assistant that you might have on your desktop that organize your emails, the tag that you mentioned the date in your email or attachment and you didn't attach anything to your email, these are all based on these systems and algorithms. So these are all applications in NLP, and this is becoming actually a very attractive job position for a lot of linguists. And I think it's a very promising interdisciplinary field that can help us, that can help people in the future. And this is where I will end for today. And I don't know if we have any more time for some questions.
Thank you very, very much, Miss Bojana Ristic, and thank you each and every one of you, the attendees, for your participation. As you all agree, that presentation is by itself a mini encyclopedia on the topic of linguistic. We have got a lot, both in terms of the terminology used in the industry and in terms of what linguistics are all about. We've learned, for example, that linguistics are indeed essential in every single aspect of our life. It is critical for experts in the field to do everything possible, whether we go through assessment, diagnostics, forensics, therapy, etc., everything in order to either alleviate or totally undo or resolve language issues. This has been really outstanding, Ms. Bojana. I personally love it, and I'll keep that very, very preciously so that I can check on this. I am working in the industry currently. So whenever there is a blank somewhere, I'll just jump in there and, get the meaning of the implications and so forth and so on. But yes, pretty much like you said, number one, I would very highly appreciate the commitment of yours to come back, because I'm certain that our participants would love to have you back again. One of them did say this has been by far one of the most important live class sessions at Atlantic International University, and I personally would agree on that. But yes, we do have a few hands up, and we would allow them to ask the questions. going first to Andrew. No, before going to Andrew, I think Andrew did ask a question earlier. Let's first turn the floor to Lombayi Yunga. Lombayi, it's your turn right now.
Good morning, everybody.
Good morning.
I have just a question to our doctor, and you know, I want to know in which parts, like of the body, that's, you know, other people stuttering, you know, when you don't speak well, like stuttering for the word to come out difficult. So how do you go about that? Like you see the stuttering people. So which part of the brain does coordinates that?
Yeah. Stuttering is seen as a speech problem,
Yes.
not a language problem.
No,
So,
I mean speech problem, yeah.
yeah, it's related to the motor, to the articulation of the language. So what it could be related to the parts of the brain, it could be related to the frontal and mortofrontal cortex. But it is believed that with stuttering, there is no problem with the motor cortex or anything, but simply with the speech apparatus, and the practice of the communication between the speech apparatus and the brain. So the language function is completely fine and intact. It is about the communication with the speech organ, and we know that the therapy is very successful with stuttering, which boils down to basically having certain practicing certain ways in which to pronounce things, and then over time it really improves. Yes. So it's an articulation issue. Yeah.
Okay, thank you so much.
Thank you. Thank you. Do we have any?
No, please.
We don't hear you. Sorry.
I apologize.
Sorry.
I was saying that there are some aspects of clinical linguistics which I personally am not very familiar with. In that context, there is a question coming from Marze Shabdiz, actually a comment, which I would like you to elaborate further on. She's telling us for improving, in order to improve learning languages, we would need to increase power of our brain with exercise and consuming vitamins B1 and B12 in order to create new cells in our brains. What is your stand on that, Bojana?
I honestly don't know anything. So this is a clear medical neuroscience issue. So definitely the case is whatever improves the state of any parts of the brain, of any cells, will improve the state of the cells of the areas of the brain that are language related. So it is true that a lot of factors will affect how your brain creates synapses, which are the connections between the cells. However, our cells are mostly made in the first 6 to 10 years of our life. This is the language, the brain plasticity period. This is why it is believed that a person who hasn't acquired a language by the age of 6, 7 won't ever be a native speaker, because the brain more or less gets rid of all the cells that it doesn't need by that time. And then after that, we don't get a lot of new cells. The neural system is not like, for example, our skin that regenerates very easily. So I am not sure about this simply because it's not my field, but I can say that whatever improves the function of brain in general will improve language function for sure.
What we need to do, ladies and gentlemen, just go ahead and do it in order to improve language functions. What is your position on that, Acacio Edu? Please turn your microphone on, and we are ready for you, Acacio. Acacio Edu? We are losing Acacio.
Hello?
Yeah.
Go ahead, Acacio.
You understand me now?
Yes, I can
Hello?
hear you. Yes, we hear you.
Yeah. Good evening.
Good evening.
Hello.
Yes,
Please.
we hear you very well, Acacio. Go ahead.
Okay, my question is, sometimes the atmosphere, the atmospheric phenomenon affect our communications. What could be the impact between the computers talking about the natural talking about the natural phenomena?
Could you be a little bit more specific by natural phenomena?
Yeah. Sometimes, for example, in our country, when it's raining, that affect all our communication or so much. The speed is becoming, sometimes it's coming down. It's coming down. The speed or the computer is coming down.
I'm sorry, I don't understand the question quite. Sorry.
If I may interject real quick,
Yes.
Ms. Bojana, my understanding is that that particular question being raised is apparently outside of the arena of linguistics. If I understand Acacio very well, as he's referring to natural phenomena, and we can think, for example, of something like thunderstorm or hurricane, for example. And of course, if there is issues with the network, physical issues caused by natural phenomena, like he's saying, this is completely unrelated to linguistics, like you are telling our attendees, Bojana. So in this case, Acacio, I understand that it's a physical issue. So all that can be done is to wait that, you know, the system is restored following the natural problems. Until then, communication can be reestablished. But let's also now go quickly to Favor Bolawa. Favor, if I'm saying the name correctly, go ahead, please. We are ready for your question or comment. Bolawa. And the sound is unclear. The sound doesn't reach us at all. I'm so sorry, Bolawa. We are not getting any sound. Can you try again? My suggestion to you, Bolawa, is you turn the video off. Some system cannot accommodate both the microphone and the video due to bandwidth issues. So turn the video off so that there can be a larger bandwidth for the microphone for the sound. Go ahead, Bolawa. Now, the video is off, Bolawa, but the sound is also off. So you need to keep the microphone on. All right, so we are losing Bolawa completely. Miss Bojana, Dr. Bojana Ristic, once again, I want to, on behalf of the entire institution, Atlantic International University, on behalf of our students, our participants as well, I want to express our total gratitude to you. Your presentation was definitely world-class, and we could use a better word if that word existed to qualify the outstanding presentation you've just made for our students. We are very, very thankful to you. And I also want to remind our participants that the entire session will be live, will be on their student portals within a few hours or days. When I say days in the plural form, I'm talking about maybe 2 or 3 days, no more than that. You go back to your student portal, you will find that recording. I don't know if you want to make a final statement, Miss Dr. Bojana, but again, thank you very much. The floor is yours, Doctor, for your last statement.
Thank you. I would just like to thank everyone, first of all, for inviting me here. It's been a pleasure. I always love talking about these things, especially because I am not particularly working in applied linguistics, so it's always good for me to remind myself how linguistics, as you said, is omnipresent and can be used in many things, especially nowadays when we use computers. It's been a pleasure, and I am really thankful for all the questions and interest. That's really rewarding for me. Thank you.
Wow, I am amazed. I am delighted. I'm pleased. I'm happy. Thank you very much, Dr. Bojana Ristic. Thank you everyone for your participation. The next session on AIO platform is tomorrow at 10 o'clock Eastern Standard Time, 5, 6 o'clock or later in some other countries. We will be waiting for you again tomorrow at 10 o'clock. Thank you, everyone, and have a wonderful Tuesday. And be blessed.